Hey everyone, Vessel here. I wanted to take a minute or two to go over the answers to deviations, variance, and standard deviation from last week. Let's jump into that today. And as a reminder, there was already a video about the introduction to the notes. So if you need to look at the notes again, I want to see some information about that. Check out the introduction video. I'm going to jump into just getting some answers here. And during class I gave a demonstration on how to use Google Sheets or Excel to get these numbers, and what I wanted to give a brief demo for on the video here is how you can use your calculator if you have one. So for those of you that do have a TI or something similar, you could use this as a way to get these statistics as well. So to speed things up a little bit, I've already input the data, but if you push statistics or stat and then your edit screen here is where you enter all of your data. So just as the screen as a whole, edit will put some numbers in for you. You can sort your lists either ascending or descending. You can clear a list from this screen, and the setup editor, which is usually used when a list is missing. Sometimes people will delete a list on accident, and the setup editor will just reset that. So that might come in handy. We use the calc screen a lot. Under this, you'll notice the most popular one we use is one variable statistics. So pretty much everything in this unit is one variable statistics, meaning it's just a single list of data. Eventually we'll use the two variable statistics, and then some of these other features we might use, we might not, kind of depends, but there's a lot of things you can calculate. So anyway, in L4 I have put the active heart rates, and in L1 I have the resting heart rate. So if you remember, we've got these two different lists. They were a real experiment we did several years ago where we had kids measure their heart rate and then have them do it like jumping jacks for a minute and then measure their heart rate again. So these were data from many years ago actually, but it was actually measured in class. And in order to get, the first thing we need is the mean. So what we're going to calculate ultimately is like these average deviations. So we need the mean first, and to get it we push statistics again and go over to calculate, one variable stats, and you get this pop-up menu. So the list you want to do your statistics on is L1 in this case. Frequencies are used when you actually have counts. So we don't have that in this case. We leave that blank and then calculate, and we'll get everything we need. The first number is the mean. So I'm going to make sure we have that. So our bar is 70 beats per minute. And then a couple other things that you might want to know. The sum. So the next number down is the sum of all these X's or resting heart rates. This one you'll never use. Well, I shouldn't say never, but it's rarely used, and we probably won't need it. But if you ever want to square your data points and then sum them up, that's what this is. Here's your standard deviations. So both of these are standard deviation, and we are actually going to calculate this one here. So when we get done with this process, we should get 13.7. But this is for a population standard deviation, and this one's for the sample. So in this case, we're using the population standard deviation because we don't really have a data set from a sample. We just have these 20 numbers. So it's more appropriate to use sigma in this case. And this x, it doesn't look like it. It's a subscript actually. So sigma x, it would be better if it showed up more like this. But it's just the saying that, okay, all of my data points, we're calling them x's, and the mean of these x's are 70. And then the standard deviation of these x's are 13.7. If it happened to come from a sample, then we would say the standard deviation is 14.1 or 14.06. So you notice they're similar, but they mean the same thing. So in order to get the deviations, we can do this by hand. We can just take our resting heart rate number and just subtract off the mean. So 92 minus 70, well, we can do that in our head. That's 22. And then we can actually take that number, and we're going to end up squaring it. And we'll do those in a minute. But we can do these by hand. That's 484. And you can, like I said, just keep going that way and get all your values. But it's going to be a lot more efficient just to use your list to calculate. So that's why I wanted to give this calculator demo today. Like I said, I did this with Google Sheets the other day, but in order to do this in your list, you can have the calculator to get all of your deviations at once. You need to put your cursor at the very top on L2 up here, not here. You'll get an error. What we're going to use is we're going to tell the calculator that L2 is going to equal, that's why it already starts with an equals, it equals L1 minus 70. So this will actually compute every single deviation for us, and we can just write them down. I'm not going to write them all down now, but what I want to point out is some are positive, some are negative, and that's of course going to happen. Some of these numbers are below average. If you were to average this list, you would see that the deviation has a mean of 0. So that's the problem with this column. It's got positives and negatives that kind of balance out. So we don't want the negatives, and that's what L3 is all about. we square these numbers in L2 to make them all positive. So again, cursor on L3, I'm going to tell my calculator to use L2. Oh, by the way, to get L2, you push second, and then 2 down here. That's shift 2 is L2. And then not subtract, sorry, we're just going to square it. So square button's right here above log. And this will make all of our values positive. It also makes them larger too. So we're going to have to handle that problem. So as we're kind of working through this sheet, calculate the deviation. So it's more of a check mark. Did that. What value is the closest to the mean? Well, if you look through your list here, you just sort of find out which one is close to the number 70. And it turns out student 17 was the closest, because it was the mean actually. So student 17 is the closest to the mean. He has a deviation of 0. And then the furthest from the mean, we're just going to try to find the one that has the largest deviation, basically. So if we scroll through, I think I know by memory, but just going through here, there was a 28, and this kid here is the largest deviation. The student had 39 beats per minute. So 30, that's student 20. Student 20 had a negative 31 deviation, and student 17 had a 0 for a deviation. So relatively speaking, you can kind of ignore the negative, basically. So this kid was further away from the mean than all the other kids. And then the next step, calculate the deviations. We've done that. And I'm not going to write them all down. Hopefully you had them in your worksheet. But squaring everything makes all those numbers positive. So that's the thing that I really just point out in the calculator. So even though this kid had negative 31 beats per minute below average, the squared deviation is 961. So what do we do with all these things, right? So we've got these deviations. They're actually useful numbers. We've got these squared deviations, which don't seem as useful. It's because they're not. But what we're going to do with them, we're going to kind of undo these two steps. So what I mean by that is we're going to figure out what the average one of these is, average in L3, and what we'll do with that number is then we'll take the square root. So we'll undo that squaring piece. So when you got to step 3, and I was getting several questions with number 3, calculate the mean of the squared resting heart rates. That's just asking you to calculate the average of this column here, which is my L3 in my calculator. So this last number was 961, and this was 25, and so on. So we're just going to average these numbers up, and the fastest way to get that average is going to be to take the one variable stats on L3. So we're going to calculate, go over to hit statistics, go over to calculate, and then use L3 this time, second 3. And the top number, this is the mean of that list, and that number is the variance. That's what this symbol work here is saying for you to do. So this number is 187.9. And the thing that is really, really weird about this particular value is the units. And it's going to come up in the next part here. So what I mean by that is, remember what these units were in the first place. So back in my list here, these were measured in beats per minute in L1 here. These were measured in beats per minute. Just some are positive, some are negative, because it's a relative number to average. But when you square this number, not only do you square the number, you also square the units. So if you've got length times width, and those are both measured in meters, you're all of a sudden going to get an area measurement in meters squared. And that's the same thing here too. We're taking the number 22 beats per minute, multiplying it by another 22 beats per minute. So this is 484 beats squared per minute squared. And that has no meaning. So that's kind of the problem with this number. And it's got a name. This number is called variance. And we'll use that later on. For now, it's just kind of nice to get the definition of this thing out here. That's why I had this specific step, kind of like a place to stop for a minute and just look. So 187.9 is called the variance. But again, we don't use this number in context because the units are a little difficult to put into context. And this is maybe even too loose. It's impossible. What is a minute squared? Like, you can't really wrap your head around that. So the units are beats per, whoops, let me say it this way, beats squared per minute squared. And that's just a really useless value. So how do we fix that? And that's a pretty easy fix, actually. So since we squared all this stuff up here, all these numbers, these deviations, what we're going to do to undo that squaring is just take the square root of it. So that will take the square root of the number, but it also takes the square root of those units. So this formula and this formula are identical, except for the fact that this one has the square root. This one says sigma squared. That is the symbol for variance. Sigma is the symbol for standard deviation. And if you just take the square root of that number, so in this case the square root of 187.9, what you're going to find, I'll go back to this here, let's just get that number, see that again. So we're going to take, in our home screen, we'll just type it in, square root 187.9, and that number was 13.07. And just as a check, remember early on I said we're going to get that number, 13.7? So 13.7, 0766209. Let's see how close it came. There's probably a little round off here, but let's check that out. So remember the one variable stats on L1, the original list. If we just want to get the standard deviation, 13.707666209. It's actually an identical match. So there's not even any round off error here. So the whole point of this activity is to sort of see how it's calculated and check out that process. But typically we're not going to do this process. We'll be able to just find our value. So this is going to be the shortcut version in the future where we just want to find this number, 13.7. That's the spread of beats per minute per student in this case. So that's the expected deviation. So that's a really important measure. It's a measure of spread, and we use it when we do these descriptions. So that's the whole process for getting our standard deviation calculation here. And then in the other data set, it's the same thing. I'm going to get the numbers here so you can have the values, but the explanation is identical. So over here in L4 is my data set. In L5, I'm going to put the deviations. And here's something that you shouldn't have done actually, but I'll show you how you can get it in one step actually. So ultimately I want L6 here. So L6, I'm going to skip right ahead and put it over here for a second. Oh, I got numbers. So if you happen to have numbers in a list, don't hit delete. Delete's going to clear out the whole, delete the list actually. Hit clear and then enter. I'm going to clear it out here. So check this step out instead. So in L6, I'm just going to jump right ahead. Put your cursor on top. Start with a parenthesis. Remember the formula. It was the AI means the active heart rate for the ith student. So A1 is 114. So I'm going to take this 114. I'm going to subtract off the mean, which was 106 by the way. You probably know that, but if not, the answer to this one's 106. So I'm going to take this L4 for all my cases, second 4, subtract off 106, and square it. So I'm actually skipping over step 5. I don't even really need that number for my purpose here. You should have these numbers for your worksheet, but if I wanted to, I could skip that step. I had the mean. I just need to find how much of a difference there is from the data point to the mean. I'm going to square that number. So this is a jump ahead. And then I'm going to average this list. One thing you might notice just visually, this is way higher spreads basically. So these squared numbers were much further apart from the mean than the other data set. So I'm going to calculate the mean for L6. And this is the answer for 3 for active heart rates, 478.8 beats squared per minute squared. And then the square root of that, 478.8. That's the standard deviation for the active heart rate, and it's 21.88 beats per minute. Beats per minute. So again, the emphasis here is these do have meaning. They're in the exact same units as our mean in our data set, and that's an extremely useful number. So again, what it represents is a spread. How spread out is your data? Well, on average, the active heart rates are 21.88 beats per minute from the mean. So we use this one quite a bit. Which brings me to the next problem here. Here it is, sorry. So I already filled this one out a little bit, and I made a small mistake, so sorry about that. I didn't have a backup histogram or chart here, so I went through and just counted out my data in each of these displays, and I think I gave some demonstrations on this in class too. But one of the things that I wanted to be able to make was making the histogram. So the mistake here was I just put the tallies in the wrong row. So there was 5 data points in the 80s, and I just shifted it, so made a little error there. So I fixed it down here for the most part. The green display is the correct display, and then this dark blue / purple one is now correct. This is not actually in the That's gone. So what I wanted to use the display for was to do number 6, describe and compare. So this is the big goal for what we've been working on the last couple of weeks. And you know, every time we do this, we got to do the same 4 things. We want to talk about shape, outliers, center, and spread. So, you know, if it helps, this is our acronym SHOCKS. And when we do this, we also need to mention the context in all of these cases, you know, and all along with a comparison statement. So I'm going to start with what I think is the easiest ones to start with. And in this particular case, I think the center and spread are probably going to be the quickest and easiest because we've already got our center and spread. We've been working with them and counting those. So you should just use your mean, and you should just use your standard deviation. There's no reason to go out and get the medians. There's no reason to go out and get your IQR or range. You don't need to do that. You know, if you chose to use those measures because we had been using them, that's perfectly fine. But really, I think using center or using mean as your measure of center would be perfectly fine here, and probably the easiest thing to go and do. So I'm going to start there and just write something like the mean resting heart rate was 70 beats per minute compared to the active rate of 106 beats per minute. And yeah, I didn't actually use the word lower or higher in this case, but you don't really need to if you give the specific value here. So 70 beats per minute for the resting, compare that to 106. So that in the mind of the reader, you get a real quick sense for what the centers of these two distributions are. Similarly with spread, you know, you could go back and get some other measures, but really just use the standard deviation. We just found it, so let's use it. So in this case, the standard deviation resting heart rate was 13.7 beats per minute, where active was higher. Get a comparison in there this time. At, I forgot the number actually, 21.9 beats per minute. So again, the overall theme here, you don't need to do everything with measures of center and spread. Pick one. You know, if it's easy to get to, go for it. But you want to keep it pretty concise, keep it straightforward and simple, and make sure that you mention a specific measure. So I don't want to just say the center. I got to give the specific statistic that I'm using. That's why I use the word mean and standard deviation here. Don't use sentences like the spread for the resting heart rate is less than the spread for active. That's not specific enough. It doesn't tell the reader what the stat you're using is. So be specific in these statistics. Outliers is a real quick check. You know, if you're pretty sure there aren't any outliers, then you can just say that. In this case, if you want to do the actual check, the version you should check, put the formulas up here, is the mean. Let's do the lower bound. The lower bound is the mean minus 2 standard deviations. And the upper bound is the mean plus 2 standard deviations. And just from the visual, there's definitely a point that looks like an outlier. We should just double check that. It looks like this one's an outlier. Maybe over here too. You see how it's kind of separated from the path a little bit. So it's not that difficult to do the check. You know, the value for the check is just taking our number 70. That was the mean. We're going to take away 13.7 times 2. So 42.6 was our data point below 42.6. And in the first case, it was, I believe it was 38 specifically. It was 39 actually. So 39 is an outlier. So 39 beats per minute in resting. And just to compare, let's make sure, just double check the upper bound. 97.4. Were there any numbers above 97.4? There was a 98. So student 11 is also an outlier. And I could identify that with the student number or the beats per minute. Just to contrast, I'm going to switch colors here. So the other data set, pretty sure this one's an outlier, the lower bound here one, but just to double check that one, this one does have a bigger spread. So I take the mean, subtract off 21.9 times 2. Just doubling that. Oh, sorry, you can't see it again. 106 is the mean, take away 21.9 times 2, and this value is 62.2. Now, I mean, one of the beautiful things about using a histogram, you can mark your outlier cutoffs right on it. Here's my cutoff. So I clearly have an outlier down here, and that value was in the 40s, 48 beats per minute. So same student, 48 beats per minute. And then checking the upper bound, just push this cursor up to that entry again and push enter, and it copies it for you. Just change this to a plus. 149.8, which is not an outlier on the upper bound. So that's above all my data points there. So just the one outlier here. And again, you don't need to go into any detail on this about why it's outliers. If you had to calculate it, it's probably on your page somewhere, but you just need to mention them. So if you knew they were outliers, you can just say them. You don't have to calculate them unless you're told to calculate outliers. And then finally shape, and I left this one last because it's really the most difficult one to do. It's hard here because of the small data set, and there's lots of things that I think would be okay for students to write in the shape. You know, one thing that it's just really difficult with the way this histogram looks. I think a lot of students might say this is fairly symmetric. You know, you see this peak in the middle and a couple of points on this side. Because it could also, I don't know, we could also describe this one as slightly skewed, but I really think that calling it symmetric is fine here. So I'm going to say something like resting heart rate has a fairly symmetric distribution. And maybe a better way to even describe this one would have been to compare to the other one. So one thing that's definitely safe to say is that resting heart rate is more symmetric than the active heart rate. The active heart rate, it's pretty level for the most part, but then there's this outlier which does have potential for skew. So I think saying that this one's kind of symmetric or skewed left is fine here as well. So again, shape's super hard with this small data set. Usually they're not going to be as difficult to see shape. So you know, that's when you use soft language. I'm going to use slightly skewed left here. But if you thought this one was fairly symmetric, that would be okay too. So active heart rate has a slight left skew. I kind of wish I hadn't penned in my responses before I wrote them in there, so it kind of felt like I was squeezing it in. But you know, these are the big four. Make sure you hit all four in context, and keep it simple on yourself. Pick the statistics that are easy to get. So you know, that's the big overarching advice. And because this video is kind of long, I just want to get the answers for this last one out here. So I went through and calculated the the Vox plot for this particular one, and I even marked the mean on it. But what I wanted to get is the standard deviation here. So let's get the standard deviation. And the reason that this would have a little bit of a contrast, if you read the prompt carefully, it says on June 19th, 2019, I took a random sample of 10 students. This was true, by the way. I actually did that. And the random sample came from our class, but it was from a larger population. So that means that technically you should not use the population standard deviation. You should use the sample standard deviation. So I want to show you where you can get that. And this would be a case where you should probably just do this in the most efficient way possible, which is just typing these numbers in and getting the value, just writing it down. You know, you can do this in Sheets, you can do this in the calculator. I got my 10 numbers in there, and in L6 the mean is 3.4964. This is the best standard deviation to use here. It's the appropriate one. So I bet many of you use 0.471 GPA. 0.497 is the sample standard deviation, so we should use that here. So the sample standard deviation is the appropriate one to use. And again, it is a sample from a larger population. So that's the difference in when you should be using this version of the calculation versus this one. If I only had 10 students in the whole school and this was their average, or this was their list of GPAs, then I would just use this one. But since it's from a sample, I should use the sample statistic here. So that's really about all I wanted to make sure I went over. Again, this video is running a little long, so you could make a box plot or a dot plot, which is here, and then describing these distributions again. So since I have the statistics, I would recommend you use mean and standard deviation. It's pretty quick to do that for measures of center and spread. You also have a really quick display here of, you can get the range, you can get the IQR, and you can check those values really quickly as well. So anyway, I wanted to wrap this up, say thanks for watching, and hopefully this is helpful information. I will talk to you soon, and take care.